So, good evening, students. This is Dr. Dong. Today, we're going to talk about the interprocess communication. So, in a previous lecture, we learned the motivation for us to have threads. So we said that we can take thread as a lightweight process, and actually we can have multiple threads within the same process. And the advantage of thread is that each thread can grab a core, and if you have multiple cores in your CPU, basically if you use multi-threading, you will be able to have multiple threads running at the same time, and this can help us to get a better execution efficiency. So, and besides that, we also learn several operations to create a thread and terminate a thread. So this is our content for last week. But in this week, we're going to learn interprocess communication. So, and there are actually three ways for us to learn this to allow multiple processes that reset on the same computer to communicate with each other. So, which are shared memory, message queue, and socket. So first, let's talk again. I'm going to start from the motivation. Why should we allow multiple? Why should we allow multiple processes to communicate with each other? So here we can actually define two types of processes. One type is called independent. So independent process mean if a process is independent, it means that its execution cannot be affected by any other process. So it's just run by itself without any interrupt from any other process. From any other process. Whereas there exists cooperating processes, so whose execution can be affected by other ones. So for example, I'm just going to give you an example right over here. So suppose that we are just using say the the sorry, or just when we are using web browsers to go through the internet to just to watch videos, and so we need to keep track of the other things going on our computer. So if just for example, so you may set up a parent. So if you have a kid, you may set up a parent control saying that okay, at this time you should stop your web browser and stop watching YouTube videos. So and the execution of your Chrome or of your web browser is impacted by another process which is called parent control. So and also the other case is that so process A and process B need to share some information. Okay, so we're going to talk about that later. In this case, we call them cooperating processes because its execution is affected by a different process. So so they actually there are a lot of benefits for cooperating processes. The first and the most important one is called information sharing. So previously we know that okay, if we have two processes, basically each process has a so process memory space, which is like the fraction of your physical memory that this process takes. So usually there is no overlap between them. Okay, it's like so family A has a house and family B has a house, and there is no overlap. They don't share any area in their backyard, so or in their front yard. So this is kind of like independent processes. But in case of cooperating process, the first and most important benefit is that we can allow two different processes to share information or share data, and this can give us a lot of convenience. So and also it can help us to improve the execution speed. Um, so And so here today, our main topic is how can we enable two processes which are located on the same computer to communicate with each other. So as I said, there are three ways. The first way is named shared memory. Shared memory is like we are creating a shared memory space between two processes. And this approach is faster, but it is subject to conflict. I'm going to talk about that later. And then the other way is named a message queue. So we can take a message queue as this way. Okay, we allow two processes to send message to each other. Yes, that's actually how it works. And a socket. Socket is also a way for us to allow two processes to send message to each other. But usually we use socket for two processes that are located on two different computers to communicate with each other. We usually call it inter yeah, we don't call it inter-process communication. Usually it is used for intercomputer communication, but it's possible for us to use it for two processes that are located on the same computer. It's possible, but usually we don't do that because it's not going to be that efficient. So okay, so these are the three methods which are our main focus today. And the first one is named, so now I'm going to talk about the first one named shared memory. So shared memory is like, as what I previously said, okay, usually two processes are like two families, which so they don't share any space in their house. And uh, but in case of like if in real life, if we have two families that are or two neighbors uh, and which have a very great relationship, what they can do is that they allocated a shared space. They allocated a shared space in their backyard so that their kids or these two families can go to the same area so that two families can, for example, have a picnic or say have a barbecue or share the same swimming pool. Okay, so this is the idea behind shared memory. If two processes and need to communicate with each other a lot, so why not we just create a shared memory space between these two processes for these two processes so that process A can put some information in the shared area, so, and then after that, process B grabs that information, reads that information, and put some new information in that area, so that process A can read it, and this is a great way for us to allow. In this way, we can allow two different processes to communicate with each other. Um, and this is going to be very efficient because we don't need to so bring a phone and type in a message and send. No, we don't need to do that. We just it's pretty much like we just leave a sticker on in the shared area, and then the other people just grab it and read it. So it's more efficient. However, one drawback of this method is that when these two processes want to write data to the same place at the same time, then there is a conflict. We can try to understand it in this way. Two close friends, decide to share the cost of buying a car so that they share a car, but and usually there is no conflict between them because when the person A needs the car, person B usually does not need that. Similarly, when person B wants to use the car, usually person A does not need to use the car. But the thing is that when just at some occasion or by some opportunity, if these two people want to use the car at the same time, then yes, it's going to be there is going to be a conflict. By conflict, I'm not going to say it's a fight. It's just like someone has to make a sacrifice. Okay, similar here. Okay, with the shared memory space. So the problem is that when two processes want to write to the same place, then there there will be a problem, and we call it conflict. So this is the idea of shared memory. I'm just going to use a diagram to explain it in a better way. So usually process A and process B are located in different areas, different segments of the memory. What we can do is that we create a shared memory space between them so that this space belongs to both process A and process B, and both process can read and write information into this shared area. So and the famous and actually let me put it this way. So um, as I have repeated it a couple of times, in this course I don't want to give you a lot of coursework because, as I said, if you go to job market and if you go to a job coding interview, um, or if you just do a job interview for any IT related say the jobs. So actually there will be either no or very few questions related to operating system. Like I've been to more than 20 uh, job interviews, and what I can say is that I have never been asked any question about operating system. And this is the reason why I said that I don't want to give you a lot of burden, because this course is not going to be the very important course that can decide if you can that decides if you can find a job or not. So so this course is mainly to give you some knowledge. The aim of this course is just to give you some knowledge about the design of operating systems. So I try to make this course lightweight for you. Uh, the first homework is going to be released next week. So then you will have a week to work on that. So according to my previous experience, most students can finish the homework within 2 hours. So it's not an intensive work. Okay. So and here again what and actually if you are asked any question related to operating system in a job interview, okay, if you face any question related to operating system, it must be this one: the famous producer consumer problem, or the famous dining philosopher problem. It has to be either one of them. So today I'm just going to explain to you what is the first problem, named producer and consumer. So the idea in this problem, we have a producer who keeps generating new products, and whereas a consumer who keeps consuming products. So let's say these two people need a shared space for storage, okay, or need to share a warehouse, so that after the producer generates a new product, it just puts the new product in a warehouse, and then when the consumer wants to consume something, he or she just goes to the shared warehouse to check if there is anything available, and take one if it is available. So so here we can view uh, producer as we can just create a process for the producer and another process for consumer, and then we can let this obviously these two processes need to communicate with each other. When producer just produces a new product, he or she needs to send the product to the consumer for and then this is where we need the interprocess communication. So the way to implement this to enable interprocess communication between producer and consumer is to use shared memory space. So what we do is that we actually create a buffer space with a certain size. So in this example, we have a buffer space of size 9. Okay, and then um, actually, if you have taken the data structure course, probably you should know that after you see out and in, probably you should know that this is what, this is a queue, right? So out points to the element or the product that enters the warehouse first, while in points to the next available space. So when a new product is ready, it's going to be put over here. Okay, so you can take it in this way. So for example, uh, let's think about a doctor's waiting room. Okay, so here you can take it, think it in this way. We have a waiting room which has nice seats. Okay, and in the morning we have a couple of some patients coming to the waiting room to see the doctor. So usually the first patient sits over here, and then the next patient, the third patient, etc., etc. So, and then usually the patient who comes first should be able to see the doctor first. So here I'm just, it just shows that, okay, we got 7 patients already coming to the office, and the first 3 have already visited the doctor, and this is the fourth one. And actually, this one, if the doctor is available, this patient is going to be able to see the doctor first. Whereas, okay, if for the variable, it points to here, which means that if there is a new patient coming in, then this new patient should sit right after the last patient. Okay, so we basically use it use the warehouse in this way. Okay, when the consumer wants to consume something, it just grabs the product pointed by out. Whereas if the producer just generates a new product, the new product is going to be put right over here. So this is the idea of the says interprocess communication between the producer and the consumer process. So one extra thing that we need to check is that when the uh, when the producer just generates a new stuff, before the producer generates a new product, he or she needs to check if the warehouse is full or not. If the warehouse is full, which means that there is no more space for the new product, then we should let the producer take a rest. Say that I'm going to give to wait some time. Otherwise, this new product has no place to go. And similarly, here for consumer, okay. So if the warehouse is empty, meaning that there is nothing available in the warehouse for he or she to consume, then the consumer should also wait. So, and then here, this is uh, okay, this is the condition for us to check if the buffer is empty or not, or the warehouse is empty or not. And this is the condition for us to check if the warehouse is full or not. And this is the code of the producer process. So while true meaning that this process keeps this loop keeps this loop in each iteration of the outer loop. So what it does is that the producer checks if if while there is no space in a warehouse or in a buffer, it just does nothing, keeps waiting. Otherwise, it just say uh, just generates a new product and put it in a space, put it in a position pointed by in and in the shared buffer space. And similarly for the consumer, okay. So while the warehouse is empty, it just does nothing but waiting, okay. And if the warehouse has anything available for consumption, then this consumer is going to take out one product. and from the shared buffer space. And actually here what you can see is that this buffer space, this buffer is shared by both the producer and the consumer process. So this is the shared buffer. This buffer array should definitely be in the shared memory space between the producer and we should put it right over here in a shared memory between the consumer process and the consumer producer process and consumer process, so that both of them are able to access and manipulate the data in that area. Okay, so this is the idea of the producer and the consumer problem. And if you go to a job interview and if you are asked this question, you should just explain it. Okay, and the most important thing that you need to point out is that first we have a shared memory between the producer and consumer process. Besides um, so we are going to use the shared memory space as a queue or as a waiting list. So so this is that famous example. And actually I'm just going to provide you the code to do this. Okay, so we all know what is a online chatting system like. So we have two people sending messages to each other. Okay, so this is here what I want you to do, not what I want you to do, what I prepared for you is to create two processes on the same computer. So process A can chat with process B. Um, so when process A sends some in which process A can just we can implement this by using the shared memory. Okay, so we basically create a shared memory space between process A and B. So A can write some message in the shared area, and after that B just reads it, and then B just again writes some message in the shared memory space, and A reads it. So this is how the shared memory can help us to to implement a online chatting system. Okay, and to do that, we are going to depend on a programming library. So here, the Linux operating system provides us the shared memory API as the following. Okay, here we have SHM get. SHM is the short for shared memory. Get means like we just want to create a shared memory segment. SHM-AT means attach. AT is for attach. So it's like after we created the shared memory space, we attach this shared memory space to some process, and then so CTL. So SHM CTL is short for control, and SHM DT means detach. It's like we just say remove the link or exclude this shared memory space from a certain process. Okay, and so to have a better understanding of this things, let me just open up a new terminal. I'm just going to use basic one, so that it's brighter. So here, let's just say so this is this is a system call named SHM get. And so what this function takes is what this function does is that it returns the shared memory identifier associated with the key. So it takes the input as a key. The key is just a message or some random number associated with the shared memory space. Size, like what size, how large do you want it to be, and then And also we need another variable or input parameter named flag. Okay, so the flag, usually we use IPC create as the flag, which means that we want to create a shared memory space for inter-process communication. Okay, and also the other thing that we need to note with we need to pay attention to this system call is the return value. Upon successful completion of, so then a positive shared memory segment identifier is going to be returned. Otherwise, -1 is going to be returned. So usually so if, which means that if we just successfully created a shared memory space, then we're going to see a value larger than 0. Okay, otherwise we're going to see a value -1. So so here I provide the code for you. I'm just going to no, I'm just going to open it over here. Teaching. Okay, so first of all, this is the standard code for you to create a shared memory space by using shmget, this system call. So here I'm just creating a key, a random key, okay, and this is in a hex format, and then it's so this size is specified as 4096 bytes. So actually it's 4 KB. And so here we just created a space, and then if the return value, the ID of the shared memory space is smaller than 0, it means that we failed to create that shared memory space. Then it will just generate some error message. Otherwise, it just print out say created the followed by the ID of the shared memory space. So here we can just execute the code to say, okay, we just create a shared memory space whose ID is 131072. Okay, and after that I help you to okay, here, oh, another thing is that we can use the command IPCS -m to check the shared memory space. So here you can see that on my computer, I just create there is only one shared memory space, and its ID is right over here, as what we just see over there, 13111072, and this is the key associated with the shared memory space. This is the owner, which is me, and the group number. Okay, so IPCS. So this command is going to report the interprocess communication facility status. So if you specify -m, it will just display the information about the shared memory segments. Okay, so and also the other thing that also I provide you the code for two processes to send message to each other. And let me show you, it's in a subfolder called online chat. Here we have Alice and Bob. I'm just going to show the code of them, okay? So on the left, we have the source code for Alice, and on the right, we have the source code for Bob. So what they do is that, so in the left code, we have Alice. So what Alice does is that so first of all, both Alice and Bob should share the same key so that they know so which memory space are they going to refer to. Okay, so Alice creates the shared memory space, and then it attaches this shared memory space to itself. Okay, and then it's going to write some message. So ask Alice to type in some message, and it's going to say print that message or store that message in a shared memory space, and then so let's look at the code at Bob. So Bob is going to say bubble depth is not going to create the space. If we use -0, it's more like we're going to check that. So if we use 0 as the flag, it's more like we're going to check if that memory space has already been created, and then it's going to attach that shared memory space to itself. And for first, it's going to receive a message from Alice, and then it's going to send out its own message. So similarly, at Alice's side, it's going to wait for Bob's reply and then print out the information sent out by Bob. So let's look at what if we execute this code. Okay, so let me say, okay, here I'm going to run Alice's code right over here and run Bob's code right over here. Oh, so permission denied, so I need sudo. Okay, sudo means you want to execute the command as a super user. And I need to type in my password. So similarly, I'm going to do this at Bob. Also, I'm going to type in my password. Okay, so it says Alice. I'm just going to type in some random message, and then here we say, okay, Alice just type in this. Let's look at Bob's side. So okay, you can see that here we got the message from Alice, and Bob is going to type in a much longer message. And here we say Bob types this. Let's go to Alice's side. So yes, this is the message that we received from Bob. So so this is the how can we implement the shared memory? The online chat system by using shared memory. So if you have interest of doing this, you can do it by yourself actually. So my code just can you can take my code as a start point and continue to improve that by yourself. Okay, so for now we just finished talking about the first way of interprocess communication, which is shared memory. And then the second way is just more intuitive. It's like we allow two processes to send message to each other, and this is called message queue. So so for message queue, there are just two basic operations: send and receive. Okay, send some message and receive some message. So here there are a lot of say the differences between different implementing methods for message queue. So there we don't need to pay too much attention to that. And so what I want to, so instead I just want to go to the example that I prepared for you, which is based on which is again a online sharing system, implementing an online sharing system by using message queue. It's like we allow two processes to send a message to each other directly. And so very similar to share memory space. First, we need to create the message queue first, and so the way for us to create it is by using this message get. Okay, so no entry for, okay, sorry, this, so this one is only available on Linux rather than Mac. So previously I told you that so when we learned the first lecture, we said that okay, Mac OS is just one extension from OpenBSD or FreeBSD. I don't remember the name exactly. The Ubuntu is just a variation of Linux. So unfortunately, the message queue, this function msgget, this system call is only available on Linux systems rather than FreeBSD. So my Mac wouldn't be able, on my Mac I wouldn't be able to show that command for you. So let's go to my server, which was Linux Ubuntu. So here's your name. Here you can see that I log on to my user running Linux Ubuntu, and let's just add message get. Okay, so message get is here, and this is a system call. It returns the message queue identifier associated with the value of the key argument. Okay, so we can use IPC private or IPC create as the message flag. So mostly likely we use IPC create, and so similar to the shared memory SHM get function. So here, if successful, the return value will be the identifier of the message queue. Otherwise, it just returns -1. So so then the standard. So and after that, okay, so besides that, let's just look at the two more functions, msg SND. So the send function and the send and the receive system call for message queue. So the send system call takes the ID of the message queue and address in your current memory space is like, so it's going to read the message from here, and it's going to send it to the queue. Okay, and then so the size of that message and also we have the flag. So this is the receive function. So it takes the ID of the message queue, and and also it takes a memory space. It's like where are you going to read this message and store it to? Okay, so and then the size of the message that you want to read. So these are the two functions that we're going to use, and let me just show you the code that I provide to you. So this is the first piece of code, which is so this is the first piece of code which shows you how to create the message queue. So it's pretty easy. We just get an ID, and then we use the IPC create flag over here. If it's successful, it's going to print out the message the ID of the message queue, and then and also in the subfolder named online chat, I provide you the function for to check how to send a message and how to receive a message by using a message queue. Okay, so this is definitely more complicated than shared memory. So this is because when we are sending message to message queue, everything must be structured. The message must be structured in a structure like this called MSG buffer. So then we're going to store the message that we want to send over here, and also we need to read it to read a message in this data structure. So and this is the example code. Okay, and you can, so if you have interest, you can explore it by yourself. And in my code, I provide some comment for you. Okay, so this is the example of showing, okay, how do they run. So at the send side, so we can let the sender type in a message, and then here we can say message is sent, and then at the receiver side, we're going to see the message being printed out. Okay, so here these are the two techniques that we can use to allow interprocess communication. And next, we're going to look at the last one named socket. So as I said before, so socket is normally used for two different processes, two different processes that reside in two remote computer systems. And okay, and the idea behind socket is this. Like, let me just give you an example. So here in the US, if you want to buy a house, and so it's not like something like you want to buy a car from a private owner. You just go to maybe Craigslist and find a car that you are interested in, and then talk to the seller directly. No, this is not allowed. At least this is not allowed in the New York State where I live. So so here in my area, it's like if you want to buy a house, you need to find your own agent, and then the seller also needs to find his or her agent, so that okay, when you want to buy it, when you are after say if you are interested in a house, and then you cannot talk to the seller directly. Instead, if you want to talk to the seller, you have to pass your message to your agent, and then your agent is going to pass the message to the seller's agent, and then the seller is going to pass that message to the seller. So here the agent is like is like the representative for both the seller for so sorry both so both the seller and the buyer have a separate agent, which serves as a representative for them to communicate with each other. So socket is pretty much the same thing, okay? So if we have two different processes want to communicate with each other, we just create a socket for process A and another socket for process B. So these two sockets are going to serve as the agent for these two different processes. They are going to be responsible for passing the messages. And usually we use socket for two processes that are set on two remote computers to communicate with each other. So this is what I said before. Okay, we have two different hosts, and then we just need to create a pair of sockets for them to communicate. And I'm not going to talk too much about a socket because this is because you are going to learn socket and socket programming intensively in your computer network class. This is more like computer network because it allows two different hosts two different hosts in two different networks to communicate with each other. And this is just like a network. This is going to be discussed in your network class, so I'm not going to spend too much time over here. What I want you to know is that socket is you can usually use socket for two processes on two different computers to communicate with each other, but it's possible for you to use them for two processes on a single computer to communicate with each other. But in practice, we don't do that because it's not efficient. Okay, so and also I provide you some code for socket programming. If you have interest, you can read it by yourself and also go through the slides. Okay, so the last thing that I want to talk about is that if you use Windows, actually Windows has a utility named remote process call, remote procedure call, and this function is very powerful because say if you have the so it basically allows a person a remote process to control your computer. So for example, if your mom is experiencing some difficulty with her computer, so she can call you so that she can allow you to control her computer remotely and solve the problem for her. And if your mom is using Windows, and Windows provides this one called remote procedure control, and this is so and you can just use this one, the remote process control to control her computer. Just a remote procedure call to control her computer. And actually this function or this utility is utilized by many say softwares, for example Zoom. Okay, and this is pretty much that. Okay, this is pretty much what I want to introduce for today. Today our lecture is relatively lightweight. It's not that important, but again I encourage you to go over the coding the code that I provide for you. Okay, so have a great week, and I will see you next week.